Section 5, we will begin discussing multiplying polynomials. If all the polynomials are monomials, remember that means one term, then we will use the associative and commutative properties. Simply, we will rearrange and put the constants next to one another, put the variables next to one another, and then use the product rule with variables that we learned in Module 5, Section 1 to combine those variables together. However, if any of the polynomials are not monomials, we will use the distributive property before the associative and commutative properties. Then we will combine like terms. If we multiply two polynomials, then we multiply each term of the first polynomial by each term of the second polynomial, and then combine like terms. Let's try a few examples. In each of these examples, we have at least one monomial. And so we will use the distributive property on parts B and C. Part A, we simply need to rearrange our factors. We have 3x squared times negative 2x. So if we rearrange these, I'll put the constants next to one another, the constant coefficients, and the variables next to one another. So we have 3 times negative 2 times x squared times x. 3 times negative 2 is negative 6. Now remember, when we are multiplying the same base, which is the case with x squared and x to the first, we add the exponents. So that will become x cubed. For the next example, we have a monomial 4x being multiplied by the polynomial 4x cubed plus 8. So let's use the distributive property. We distribute 4x to each term inside parentheses, which gives us 4x times 4x cubed plus 4x times 8. Now, instead of rewriting each factor so that our constant coefficients are next to one another and our variables are next to one another, I'm just going to work through the problem, which you can as well. So with the first product, 4x times 4x cubed, 4 times 4 is 16. X times x cubed, remember the first x has an exponent of 1. We add those exponents and that becomes 16x to the 4th. For the second product, 4x times 8, we multiply the constant and the numerical coefficient. 4 times 8 is 32, times x is 32x. We will go through a similar process on part C. We'll distribute the negative 5x squared to all three terms inside parentheses. That gives us negative 5x squared times 2x squared plus negative 5x squared times 7x plus negative 5x squared times negative 2. Let's go back and multiply each product. Negative 5x squared times 2x squared. Negative 5 times 2 is negative 10. X squared times x squared is x to the 4th. In the next product, negative 5 times 7 is negative 35. X squared times x will become x cubed. Remember, we are adding the exponents. And in the last product, negative 5 times negative 2 is a positive 10, times x squared is just 10x squared. We have no like terms, so at this point we are finished. Examples where we are multiplying polynomials by polynomials. Remember, the directions told us that if we have a polynomial times a polynomial, we multiply each term in the first polynomial times each term in the second polynomial. And I'm going to represent that with arrows. Starting with the first term in the first polynomial, it will multiply to every term in the second polynomial. Then we go to the second term in the first polynomial, and it will multiply to every term in the second polynomial. So let's write down our products and then combine like terms. We start with the first product, the first arrow, y times y plus, and then go to our second arrow, y times 7. We then move to our third arrow, plus 5 times y, plus, we move to our last arrow, 5 times 7. Let's go through each product and simplify. Y times y is y squared. Y times 7 is 7y. 5 times y is 5y. And 5 times 7 is 35. As we look at this algebraic expression, we see that 7y and 5y are the only like terms involved. So we combine those and it gives us y squared plus 12y plus 35. Let's go through a similar process with the next example. So we take the first term in the first polynomial, which is 2x. We multiply it to each term in the second polynomial. We then go to the second term in the first polynomial, which is negative 4. We will attach that minus sign to the 4, so negative 4, which will multiply to each term in the second polynomial. This time I'm going to write the product as we go instead of each factor. So we start with 2x times 7x. 2 times 7 is 14. X times x is x squared. We then go to the second product. 2x times 5. 2 times 5 is 10, times x is 10x. Now the third product, negative 4 times 7x. Negative 4 times 7 is negative 28, times x is negative 28x. And finally, negative 4 times 5 is negative 20. Again, we see we have two like terms, the 10x minus 28x. So when we combined our like terms, we're left with 14x squared minus 18x minus 20. Multiply when we have a polynomial raised to a power. So let's multiply 3x plus 4 squared. First, let's remember what the exponent means. If we had x squared, that means we would have repeated multiplication on the base of x, or x times x. The same is true for polynomials. If we have 3x plus 4 to the second power, then we have repeated multiplication of 3x plus 4. You must rewrite your polynomials this way. You cannot simply square the first term and square the last term and be finished. That will always give you the wrong answer in this class. So we rewrite the two sets of parentheses that we have because we have repeated multiplication. And we go through the same process we did before. The first term in the first set of parentheses times every term in the second set. The second term in the first set of parentheses times every term in the second set. And then let's write the product as we multiply. 3x times 3x, 3 times 3 is 9. X times x is x squared. The second product, 3 times 4 is 12, times x is 12x. Now the third product, 4 times 3x, 4 times 3 is 12, times x is 12x. And the last product, 4 times 4 is 16. We see that we have two like terms, 12x and 12x. When we combine those, we get 9x squared plus 24x plus 16. Another example of a polynomial raised to the second power. We will work it the same way we worked the last problem. So we rewrite this as repeated multiplication, 5x minus 2z, 5x minus 2z. We multiply the first term in the first set of parentheses times each term in the second. The second term, which we're going to call negative 2z, times each term in the second set of parentheses. And writing the product as we go. So first we look at our first product, 5x times 5x. 5 times 5 is 25. X times x is x squared. Then our second product, 5x times negative 2z. 5 times negative 2 is negative 10 times x times z. So we have negative 10 xz. Now we look at our third product, negative 2z times 5x. Negative 2 times 5 is negative 10. I'm going to write the variables in alphabetical order. It's easier to see like terms if we will do that. And then the last product, negative 2 times negative 2 is a positive 4. Z times z is z squared. We can now see we have two like terms, the xz terms in the middle. We combine those and we get 25x squared minus 20xz plus 4z squared. Multiply two polynomials when each of those polynomials has more than two terms. So in this case, we have one binomial in a plus 2. We have a trinomial, a cubed minus 3a squared plus 7. The only difference here is we will have more arrows. So we take the first term in the first polynomial, multiply it to each term in the second polynomial, the second term in the first polynomial, times each term in the second polynomial. And let's write the products as we go. So starting with the first product, a times a cubed is a to the 4th. Now the second product, a times negative 3a will be minus 3a cubed. And the third product, a times 7 is plus 7a. We now move to the 2. Its first product, 2 times a cubed is a positive 2a cubed. The next product, 2 times negative 3a squared. 2 times negative 3 is negative 6. Times a squared is negative 6a squared. And the last product, 2 times 7, is a positive 14. So as we go through the problem, we have the algebraic expression with different like terms, negative 3a cubed and a positive 2a cubed. And those appear to be the only like terms we have. So combining those, let's write the result. We have a to the 4th, negative 3a cubed plus 2a cubed becomes minus 1a cubed, or just minus a cubed, plus 7a minus 6a squared plus 14. An example where we are multiplying two trinomials. We have 3 terms in each polynomial. We go through the same process we did in the last example, except now we will have even more arrows. So we start with the first term in the first polynomial. We multiply every term in the second polynomial. We then go to the second term in the second polynomial and multiply every term in the second polynomial. And finally, the third term in the first polynomial. And we multiply every term in the second polynomial. So I like this method of drawing arrows to try to determine what I'm actually multiplying. You can see how the more terms we have in each polynomial, the more confusing that can become. Let's write the products as we go. We start with the first, 2x squared times x squared becomes 2x to the 4th. The second, 2x squared times 3x is 6x cubed. The third, 2x squared times 4 is 8x squared. Now we move to the next term. We move to the x. X times x squared is x cubed. We move to the next term. X times 3x is 3x squared. And the last product with x, x times 4 is 4x. Now we move back to the negative 1. Negative 1 times x squared is minus x squared. Negative 1 times 3x is minus 3x. And negative 1 times 4 is minus 4. Let's go through the problem, through the algebraic expression, and find any like terms. We start with 2x to the 4th. There are no other terms that have an x to the 4th power. So we simply write it down, 2x to the 4th, cross it out to show we've used it. The next available term is 6x cubed. We also have a plus x cubed in the problem. 6x cubed plus x cubed gives us 7x cubed. We can cross through each of those terms because we've used them. The next available term is 8x squared. We also have a 3x squared and a minus x squared. 8x squared plus 3x squared minus x squared will give us plus 10x squared. We can cross through each of those terms. Next, we have a positive 4x minus 3x. 4x minus 3x is simply x. And last, we have a negative 4. There are no other terms that it could combine with. So we bring down the minus 4, and we're finished. And finally, let's look at one example of how we would multiply two polynomials if those polynomials contained fractions. Basically, it's the same exact process. We start with the first term in the first polynomial and multiply each term in the second polynomial. Then we go to the second term in the first polynomial and multiply each term in the second polynomial, and so on, until we have every arrow drawn with every combination. So let's write down the products as we go. The first product, x times x, is x squared. The second product, x times negative 1/5, is negative 1/5 x. The third product, 3/5 times x, is 3/5 x. And the last product, 3/5 times negative 1/5, is negative 3 over 25. Remember, you multiply numerators and denominators when you have two fractions. When we combine like terms, we see we have two x terms in the middle. Now, since these are fractions, we have to make sure they have a common denominator. In this case, they do. Each denominator is 5. So we write down x squared. Combining the numerators, we have negative 1 plus 3 is 2. So plus 2/5 x minus 3 over 25.